Today we're going to do more practice with multiplying polynomials. Student outcome, what you should be able to do at the end of this lesson, are students understand that the product of two polynomials produces another polynomial. And you're also going to be able to multiply polynomials together. Exercise 1. Gisela computed 342 times 23 as follows. So she chose to break 342 into 300 times 40 times 2. And then 23 into 20 and 3. She wrote them off to this side instead of this side. It doesn't matter. 300 times 20, 40 times 20, 2 times 20, 300 times 3, 40 times 3, 3 times 2. And she got these results here along the diagonal, the 6,000, the 1,700, the 160, and the 6. It says, can you explain what she's doing? What is her final answer? She's doing our box method, which is also called the area model, because she found all the areas of these boxes. And then at the end, she added them up, and her final answer should be 7,866. We're going to practice doing that too. Letter B, use a geometric diagram to compute the following products. So, we have 3x squared plus 4x plus 2 times 2x plus 3. So since I have 3 terms here, I'm going to need my box to have 3 columns, and then 2 boxes or 2 terms here, so I need 2 rows. And then I multiply. 3x squared times 2x is 6x cubed. 4x times 2x is 8x squared. 2 times 2x is 4x. 3x squared times 3 is 9x squared. 4x times 3 is 12x. 6 times 2 is 12. I saw I had some like terms. When I add them up, I get 6x cubed plus 17x squared plus 16x plus 6. I can do the same thing with letter B. All right, I have 2 terms here, so I'm going to have 2 columns. And then I have 3 terms on the second one, so I'm going to have 3 rows. And then I multiply. X times x cubed is x to the 4th. X cubed times negative 1 is negative x cubed. 6x squared times x is 6x cubed. Negative 1 times 6x squared is negative 6x squared. X times negative 5 is negative 5x, and negative 5 times negative 1 is a positive 5. I did have one set of like terms right here, so I did combine them, and you can see that that's my final answer. Notice a couple things with the negatives. Alright, so since it was a minus 1, that's why I have a negative 1 there, and since it was a minus 5, that's why I have a negative 5 there. Letter C, the same idea, x plus 5 quantity squared. You have to realize that it's the same as x plus 5 times x plus 5. So I set up my box, and I multiply. X squared, 5x, 5x, and 25. And then you had the like terms of 5x. You add it up, you get x squared plus 10x plus 25. First bullet, what do you notice about the terms along the rectangles you drew? So, along the diagonals here, we notice a lot of the times they're like terms. Not always. This diagonal here was not a like term. But a lot of times they're like terms. Could we have found the product without the geometric model? Hopefully you can realize that yes, we could have, because we were doing that a few days ago now. What would it look like? It would be a multiple distribution. Alright, and I think we're going to do it on the next page here, so let's take a look. Yes, exercise 2 here says multiply the polynomials using the distributive property. So for the distributive property, I'm going to take the 3x squared and multiply by the entire polynomial. Then I'm going to take the x and multiply by the entire polynomial. Then I'm going to take the negative 1 and multiply by the entire polynomial. And that's the setup right here. Take a look. 3x squared times the polynomial, x times the polynomial, negative 1 times the polynomial. And then you just distribute in. Okay? So I get 3x to the 6th minus 6x squared cubed plus 3x squared. And then I get x to the 5th minus 2x squared plus x. And then I get negative x to the 4th plus 2x minus 1. I can combine like terms if there's any, which there should be. And I wrote it highest power to lowest power. So my highest power was the 6th power. Then my next highest power is the 5th power. And then my next highest was the 4th. And then the 3rd. And then the 2nd power, but the 2nd power I have 3x squared minus 2x squared is x squared. And then I have like terms on the x's. X plus 2x is 3x, and then you just have minus 1. Number 3, it says write an equivalent expression using the distributive property. For example, we have 10x squared plus 6x cubed. What I'm really asking you to do is to rewrite it as if it would have looked before you had done the distributive property. So I'm really asking you to take out a common factor. Greatest common factor would be nice, but at least a common factor. So I look to see what's common in 10x squared and 6x cubed. There's a 2 common in the 10 and the 6, and they both have at least 2 x's, so x squared. And then I'm left in this case with a 5. The x squared's already out. 2 times 5 is 10. And in this case here, I'm left with a 3x because 2 times 3 is 6. X squared times x is x cubed. There's other options. I could have had this one as well. Maybe I chose not to take out the x squared and I just took out the 2. And I'd be left with 5x squared plus 3x cubed. We're just going to practice doing that for a few of these in exercise 3. Actually, multiple. So, number 1, 6a plus 14a squared. Since 6 and 14 are even, they have a 2 factor common. And I can notice I have 1a that's common between them. 2 times 3 is 6. 2 times 7 is 14. And then I took the a out of the first one already, and I took 1a out of the second term, so I have 1a left. For number 2, 2 is common in everything. And also I see they all have at least 4 x's in them. 2x to the 4th times 1 is 2x to the 4th. 2x to the 4th times x will be 2x to the 5th. I have one more x I need there. And since I took 4 x's out of the 10 x's, I have 6 of them left there. Number 3, 6 and 15, they're not both even, so I can't take out a 2. However, 6 and 15 both have a 3 common, and they both have 1 z common. I would be left with a 2z. 3 times 2 is 6, and I need one more z there. And then 3 times 5 is 15. Number 4 must be down here a little bit more. This time I have 3 terms, so I'd look to see what's common in all 3. They're not all even, so I can't take out a 2, but they do all have 7 in common. And they all have at least 1 w in them. 7 times 6 is 42, and I need 2 more w's. 7 times 2 is 14, and I don't need any more w's, and it's a minus there because it's a negative 14. And then 7 times 11 is 77, and I only took 1 w out, so I need 4 more. Number 5, this one's a little more difficult because it's fractions. They both have 1/2 common. Okay? Now look what I did off to the side here a little bit. I have the 1/2 times something would equal 3/2. Kind of what I was doing before for numbers 1 through 4. Well, 1 times 3, sorry, it should be a 3, is equal to the 3. 2 times 1 equals 2. So that means the missing piece is a 3. So in parentheses, I have a 3. And then there's no s's that I took out, so it's s squared. And when I take a 1/2 out, I'm left with 1. 1/2 times 1 is 1/2. We're not going to worry about letter 6. Number 7, we can try. I know it's a lot of terms. I took out the most common, but you didn't have to take all of this out if you didn't want to. So, I looked at my numbers first. They all had a 3 common. For the p's, they all have at least 2 p's. And for the r's, they all have at least 2 r's. Then I just wrote what I had left. 3 times 5 is 15. I have 1 p left and 2 r's left. 3 times negative 2 is 6. And I don't have any p's left, but I do have 3 r's left. 3 times 3 is 9. I have 2 p's left, but no r's. 3 radical 2, I took a 3 out, so I have radical 2 left. I have 1 P left, and I have 4 R's left. The process of making use of the distributive property backwards, what we were just doing in the previous example, is called factoring. Exercise 4. Sammy wrote a polynomial using only one variable x of degree 3. For example, this is a polynomial, one variable x of degree 3. Maisha wrote a polynomial with the same variable, so x, with a degree of 5, and it's a polynomial. What can you say about the degree of the product? Product means multiply. So when I multiply these, I could use the mnemonic FOIL to help me. I could use my box method. I would get x to the 8th minus 5x cubed plus 2x to the 5th minus 10. The highest the degree of that polynomial is 8. One easy way I could have gotten that was, and I have it off to the side here, let me see if I can move it over. Knowing that my highest degree of the two polynomials are 3 and 5, you add them up for the laws of exponents and you get 8. We're not going to worry about the extension. And then we have, is the product of two polynomials sure to be another polynomial? Yes, it is. Always is. Is a polynomial squared going to be another polynomial? Yes, it is. We saw it today. Every time I multiplied, I still had polynomials back. I would like you guys, I know this was a longer video, but I'm going to ask you guys to try that challenge one and see what you get. Alright, use a geometric diagram to complete the product. So the box method for this one here, please. And I will look at it all tomorrow in class.